Hello everyone, I am Abhishek Naskar, Assistant Professor at the Institute of Technology. Today I am going to discuss about aggregates, which is one of the important building material for making concrete, mortar, and also it is used for making flexible pavements and rigid pavements. Here we will be discussing two topics based on aggregates, that is classification of aggregates and characteristics of aggregates. First we come to introduction, that is what are aggregates. So aggregates are basically used as filler with burning material in the production of mortar and concrete. They are derived naturally from igneous sedimentary and metamorphic rocks or artificially from blast furnace slag. Aggregates from the body of concrete reduce the shrinkage and they also affect the economy. They occupy 70 to 80% of the volume of concrete and have considerable influence on the properties of concrete. They should be clean, hard, strong, durable, and they should be well graded in size to achieve utmost economy from the paste of mortar and concrete. Now, earlier, aggregates were considered to be chemically inert, but nowadays it is discovered that they perform some reaction and they are chemically active. Certain types of aggregates exhibit chemical bonding at the interface of the aggregate and the cement paste. To increase the bulk density of concrete, aggregates are used in two different sizes. The bigger ones are known as coarse aggregates. In common terms, they are known as grit, and the smaller ones are known as fine aggregates. Commonly, they are known as sand. Now, this picture depicts the various natural sources of aggregates. So, igneous rocks, they are volcanic origin. The lava that comes from the volcanoes, they come to the earth's surface after volcanic eruption and they solidify in cooling and they become igneous rocks. The sedimentary rocks, they are formed by the action of wind, air, and water. And metamorphic rocks, that is when igneous rocks and sedimentary rocks come under tremendous pressure and temperature, they are metamorphized into another type of rock which are known as metamorphic rock. So these are the natural sources of aggregates. Similarly, aggregates can also be obtained from artificially. They are obtained from steel industries in the form of steel grit and from copper industries in the form of blast furnace slag. Coarse aggregates, they are bigger in size, what we are called known as stone chips. They are obtained from the nature as in the form of igneous rocks, sedimentary rocks or metamorphic rocks. And fine aggregates, they are generally collected from river banks. Now, sea sand cannot be used as construction material because sea sand, they are finer in size and they are also contaminated with salts. So that is why generally sea sand is not used for construction purpose, only river sand is used for construction purpose. Now next we come to classification of aggregates. Now classification is mainly done on four heads, that is on the basis of geological origin, on the basis of size, on the basis of shape, and on the basis of unit weight. Now on the basis of geological origin, the aggregates are natural aggregates and artificial aggregates. Next, on the basis of size, they are coarse aggregates, fine aggregates, and all-in-all aggregates. Coarse aggregates whose size is more than 4.75 millimeter, fine aggregates whose size is less than 4.75 millimeter, and all-in-all aggregates, it is a mixture of coarse and fine aggregates. Next, on the basis of shape, the aggregates are rounded aggregates, irregular aggregates, angular aggregates, and flaky aggregates. And on the basis of unit weight, there are normal weight aggregates, heavy weight aggregates, and lightweight aggregates. So classification is mainly done on the four heads. On the basis of geological origin, the aggregates may be classified into natural aggregates and artificial aggregates. Natural aggregates are obtained by crushing from quarries of igneous, sedimentary, and metamorphic rocks. Gravel and sand reduced to their present size by natural agencies also fall in this category. Artificial aggregates, the aggregates may be classified into broken bricks, blast furnace slag, and synthetic aggregates. Now, broken bricks known as brick beds are suitable for mass concreting, for example, in foundation bases. They are not used for reinforced concrete works. So, generally, broken bricks, that is, the bricks which are overburnt bricks, they are not used as a cannot be used as for normal breaking purpose, and they can be used as aggregates when they are broken into desirable shapes. Now next we come to blast furnace slag. It is obtained from slow cooling of slag followed by crushing. The dense and strong particles are used for making precast concrete products. The specific gravity of this type of aggregates range between 2 to 2.8, and bulk density varies from 1120 to 1360 kg per meter cube. The blast furnace slag aggregates has good fire resisting properties, but are also responsible for corrosion of the reinforcement iron due to sulfur content of the slag. Next we come to synthetic aggregates. So they are produced by thermally processed materials such as expanded clay and shells. They are used for making lightweight concrete. So as in the picture it is visible that synthetic aggregates can be made of various colors, and as a result they are more used for aesthetic purposes. Next, on the basis of size, the aggregates has been classified into coarse aggregates, fine aggregates, and all-in-all aggregates. Coarse aggregates. The aggregates written on 4.75 mm sieve are identified as coarse. The maximum size of aggregates can be 80 mm. However, the maximum size that is used for construction purpose is generally not more than 20 millimeters. Now, this is a picture of a 4.75 ISC. So, any aggregate which is passing through this sieve, that is falling under fine aggregate, and the aggregates which are not passing, that is they are written over this sieve, they are known as coarse aggregate. Now next we come to fine aggregates, that is aggregates passing through 4.75 mm sieve are defined as fine. They may be natural sand deposited by rivers or crushed stone sand obtained by crushing stones and crushed gravel. The smallest size of fine aggregate is 0.06 mm. Another variety of aggregate is all-in-all aggregate. So naturally available aggregates of different fractions, fine and coarse sizes, are known as all-in-all aggregates. The deficiency of any particular fraction can be corrected for use in the concrete mix. They are not recommended for quality concreting. Now classification on the basis of shape. The aggregates may be classified into rounded aggregates or irregular, angular, flaky, and elongated. Now we discuss all of them one by one. So rounded aggregates. So from the picture you can see that the aggregates, they are more or less rounded in shape. They do not have any rough surface or angular surface. They are generally obtained from river or seashore and produce minimum voids, that is about 32% in concrete. They have minimum ratio of surface area to volume, and cement paste required is the concrete paste required is minimum. Poor interlocking bond makes it unsuitable for high strength concrete and pavements. Now, since the surface of the aggregate is smooth, it is they are not very suitable for making good bond with concrete, and as a result, for quality concreting purpose, these rounded aggregates are not very suitable. Next come irregular aggregate. So they have voids of 36% and require more cement paste as compared to rounded aggregates. Now, because of irregular in shape, they develop good bond and are suitable for making ordinary concrete. Next we come to angular aggregates. So they are sharp, angular and rough particles. Angular aggregates provide very good bond than rounded or irregular aggregates. They are more suitable for high strength concrete and pavements. The requirement of cement paste also is relatively more compared to rounded and irregular aggregates. Now next we come to flaky aggregates and elongated aggregates. Now flaky aggregates are those whose least dimension, that is the thickness, is less than 3/5 of its maximum dimension, and elongated aggregates are those whose largest dimension, that is the length, is greater than 1 and 4/5 times its minimum dimension. So that will be more clear by this picture. So this is an example of a flaky aggregate. So here the maximum dimension is A and the minimum dimension, that is the thickness, is B. So when B is less than 3/5 of A, it is termed as flaky aggregate. Similarly, elongated aggregate, here the maximum dimension is A and the thickness is denoted by B. So when A by B is greater than 9/5, it is called elongated aggregate. Now next classification is based on unit weight. So aggregates are classified as normal weight, heavy weight, and light weight. Now normal weight aggregates, they resemble sand, gravel, granite, sandstone, limestone, etc. Their specific gravity is 23 point, that is specific gravity is 2.5 to 2.7, and the bulk density varies from 1520 to 1680 kg per meter cube. Similarly, heavyweight aggregates, their specific gravity varies from 2.8 to 2.9, and magnetite, scrap iron, these are examples of heavyweight aggregates. And lightweight aggregates, they are examples of dolomite, pmi stone, etc. Now next we come to characteristics of aggregates. Now the properties to be considered while selecting aggregate for concreting are as follows. We will consider strength, we will consider the particle shape, specific gravity, bulk density, voids, porosity and moisture content. So these characteristics of the aggregates are play a very important role while selecting aggregates for concreting purpose and also for making roads. Now the strength of the aggregate should be at least equal to that of concrete. Now, rocks commonly used as aggregate have a compressive strength much higher than that of concrete, so that is why there is no problem. And the test conducted for strength evaluations are crushing test, impact test, and 10% final test. So by these three tests, we can measure the strength of the aggregates and find out that whether the strength is greater than concrete or not. If the strength of the aggregates is less than cement, hardened cement, then that aggregate should not be used. That aggregate is not suitable for to be used in concrete paste. And next we come to stiffness. The modulus of elasticity of concrete is approximately equal to the weighted average of the moduli of cement paste and the aggregates. Our higher value reduces the dimensional changes due to creep and shrinkage of the cement paste, but the internal stress becomes also higher. Now this graph presents stress strain graph of cement paste, concrete and aggregate. The red line here depicts the stress strain curve of aggregate, and the line which is a straight line at the bottom, it is of cement paste. Now when cement paste contains aggregates, it takes a curvature shape which is seen in the graph. So stress strain graph of aggregate is actually lies between aggregate and cement paste. Next we come to bond strength. Now due to difference between coefficient of thermal expansion of cement paste and aggregate, and due to shrinkage of cement paste during hardening, concrete is in a state of internal stress even if no external forces are present. So stresses are likely to be greater at the paste aggregate interface where minute cracks have been found to exist even in concrete that has never been loaded. So under increasing external load, these cracks spread along the interfaces before extending into the paste or aggregate particles. The strength of the bond between aggregate and cement paste thus has an important influence on the strength of the concrete. Now there is no standard test for bond, but it is known that rougher the surface of the or the rougher the texture of the aggregates, better is the bond. So that is why rounded aggregates are not suitable for making good bond with concrete. Now next we come to shape and texture of the aggregates. Now the shape influences the properties of fresh concrete more than when it is hardened. Rounded aggregates are highly workable but yield low strength of concrete. Now since the surface is smooth, the aggregates have a tendency to roll. That is why the workability increases within the concrete paste. But irregular aggregates, since the surface is rough, the workability is generally less compared to rounded aggregates. Fake aggregates require more cement paste, produced minimum voids, and are not desirable. Angular shape is most desirable. The shape and surface texture of fine aggregates govern its void ratio and significantly affect the requirement of the aggregates. Now, specific gravity. The specific gravity of most of the natural aggregates lies between 2.6 and 2.7, and bulk density of the aggregates depend upon their packing, the particle shape and size, and grading of the aggregates, and also on the moisture content of the aggregates. Voids. So it is a ratio which is calculated by the formula. That is, void ratio is given by 1 minus bulk density divided by the apparent specific gravity. So if the voids in the concrete are more, the strength will get reduced. So it is inversely proportional to void ratio. Now next we come to porosity. Now the entrapped air bubbles in the rocks during their formation lead to minute holes or cavities which are known as pores. Now, generally, natural rocks, that is igneous rocks, sedimentary rocks, metamorphic rocks, they are formed by the uh, natural ingredients of the earth surface. For example, igneous rocks, when they are formed by the solidification of the lava. So when lava comes to the surface and generally they solidify under the action of wind and low temperature, some air bubbles gets entrapped and they cause pores. The porosity of the rocks is generally less than 20%. Now, if it is more than 20%, the concrete becomes permeable and ultimately affects the bond between aggregate and cement paste, resistance to freezing and thawing of concrete, and resistance to abrasion and specific gravity of the aggregate. So that is why porosity is desirable to be less than 20%. Next, we come to moisture content. Now, the surface moisture expressed as the percentage of the weight of the saturated surface of dry aggregate is known as the moisture content. A higher moisture content increases the effective water cement ratio to an appreciable extent and may render the concrete weak. Now, next we come to bulking. The increase in volume of a given mass of fine aggregate caused by presence of water is known as bulking. Now, why bulking occurs? Generally, bulking it is a property of the fine aggregate. So, when fine aggregate, that is sand, when it comes in contact with water, each particle is encircled by a volume of water, sphere of water, and as a result, the particles are pushed apart from one another, and as a result, the volume increases. Now, this water forms a film over the fine aggregate, exerts force on the surface tension, and pushes them apart and increases the volume. The extent of bulking depends upon the percentage of moisture present in the sand and its fineness. Now, this graph represents the bulking of fine aggregate, medium aggregate, and coarse aggregate. So, the maximum increase in volume is observed in fine aggregate. Then, in medium sand, it is less, and in coarse sand, it is the lowest. But the increase in volume is maximum in fine aggregates because the particles are very fine, and as a result, the increase in volume is more. Now, next we come to fineness modulus. So it is a numerical index of fineness given by some idea about the mean size of the particles in the aggregates. The fineness modulus, abbreviated as FM, it varies between 2 to 3.5 for fine aggregates, 5.5 to 8 for coarse aggregates, and 3.5 to 6.5 for all-in-all aggregates. All-in-all aggregates means it is a mixture of coarse and fine aggregates. Thank you. So this was our discussion about the classification and the characteristics of aggregates. Thank you.